9,
8,
7,
6,
5,
4, 3,
2.
1.
Hey there, folks, and welcome to Slooh. My name is Eric Edelman, and today we are going to be looking at different images taken from the Slooh telescopes, welcoming a brand new planet to the neighborhood. And that planet is Proxima-b, an Earth-like planet orbiting around Proxima Centauri, the closest star to our own. So right now we're actually looking at the all-sky view through the Chile telescopes in the Slooh network. And as you can maybe see through the screen, we're dealing with a bit of clouds here tonight. So unfortunately, when we would want to get our closer up view with the telescope, we're not going to be able to see that as it is live, but we have some images that we've taken over the past few days that we're going to be showing you instead. Because yes, weather does play into it. But yeah, we have to look at the all-sky view via Chile in the southern hemisphere because this is a southern hemisphere object. Proxima Centauri is a star in the constellation of Centaurus, and has a very interesting discovery that we're all going to be talking about here today. So the interesting thing in a lot of ways about Proxima Centauri, the star itself, is that it is so close to our planet Earth. It is the closest star to us besides our very own sun at 4.2 light years away. This star is actually pretty small. It's a red dwarf star, and it's one of the smallest stars out there, which makes it very interesting. In a lot of ways, it will be different from our sun in terms of how active it is and how long its lifespan is. And in terms of seeing a planet around a star like this, we're going to have to do some interesting speculation to figure out how life, if it's possible, might exist on a planet with a star very different from our own. And so, yes, there is that planet, Proxima-b, and it's orbiting around this star. This discovery has been announced very recently. And this planet is actually orbiting its host star, Proxima Centauri, every 11.2 days. It's very, very close by to that star. So we have Mercury that is the closest planet to our sun in our solar system. And this planet is 8 times closer to its host star than Mercury is, 20 times closer than we Earth are to our sun. So it's very, very close in. And so maybe in that respect, it sort of begs the question, why in the world would this planet maybe be considered Earth-like? Well, that sort of has to do with some of the differences that we see between our sun and the star that Proxima-b orbits. Because since Proxima Centauri is such a smaller star, it's an M dwarf, it's a red dwarf, it actually has a bit of a lower temperature than our star does. And so a planet would have to be much closer in to its host star than Earth is to our sun to have some of the similar temperatures that we experience on our planet. And so this planet, scientists are thinking, is very likely inside of this star's habitable zone. And what that means is that this planet is not too close into its host star that water would boil off the surface, and it's not too far away from that star so that water would freeze. It's in the place where temperatures could potentially pave the way for liquid water, and maybe alongside that, life. So there's a lot of questions that have popped up now that this discovery is right here on the fore. And during this show, we're going to learn a lot more about this planet. We're seeing the star system sort of in the center of the view here. There's a wonderful arrow that's pointing it out. That's the Proxima Centauri system, just taken with our Chile scopes just a couple of days back. And so we're going to take a closer look in our minds, and both with scientific visualization as well of this system. And I'll be joined actually throughout the show by some great guests that are really highly related to this project. There's Michael Endel, who is a member of the Pale Red Dot team that discovered the new planet. And a little later, I'll be speaking to Dr. Lisa Kaltenegger, who is the director of the Carl Sagan Institute at Cornell. And they actually released a paper earlier this week positing the idea that a planet like Proxima-b could support life. So we'll go into the details of why that might be. There's a lot of ground to cover, and I'm so excited you're with me to cross that distance, because this is a huge discovery. This planet is within traveling distance. And yes, we'll talk about potential ways that could happen as well. But if you have any questions for myself or the guests that are coming on this show here tonight, you can feel free to send them in. You can tweet them to us at our Slooh Twitter account, @Slooh. Or if you're watching on slooh.com, you can use the live chat, which you'll find either to the right of the show or a little bit beneath it, depending on your browser. But we would love to hear from you and include you in the conversation. So let's get started, though. This planet was discovered thanks to a team of scientists working on the Pale Red Dot program at the European Southern Observatory. And our first guest is a part of that team, and he's here to help us understand our newest neighbor. Michael Endel is a research scientist at the McDonald Observatory at the University of Texas at Austin. And thank you very much for joining us, Michael.
Thank you for having me.
And so maybe just to start us off, could you tell us a little bit about the feelings that you experienced when you discovered this? What was it like to have this discovery right in your hands?
Well, it's like most of the scientific results. It's not something that pops out like from 1 minute to the next. It's been actually 16 years in the making, at least for me. I started observing Proxima Centauri in 2000 together with Martin Kürster using the ESO BLT. And we looked exactly for something like what we found, the Pale Red Dot campaign has found now, an Earth-size or Earth mass planet in the habitable zone. And we observed this star for 7 years and concluded at that moment, we don't see any planets in the habitable zone, and that we should have seen already everything that's about 2 to 3 Earth masses. And not surprisingly, the planet itself that's found now is below this limit. And then time has passed, and other groups started observing Proxima as well. And what Guillaume Englada and his colleagues did was then to take the archival data from our older survey and the newer data, and looked very carefully at the results from a combination of all the data, and saw this very interesting signal at 11 days. But it wasn't so significant to announce immediately that this is a planet. And then Guillaume went ahead and did exactly the right thing. He designed an observing campaign to really verify whether this signal is a planet or not. And that's actually the Pale Red Dot campaign that happened earlier this year. And
so
during that campaign, we saw the signal growing stronger and stronger and stronger, and then it became clear. So it was kind of a process. It wasn't something like that from one day to the next.
It didn't just explode into view.
Yeah, it's not like we took an image and suddenly there's the planet.
And could you tell us a little bit about the Pale Red Dot campaign, what that sort of means and how it came about?
Yeah, that's what I just said, that there was this indication of a habitable zone planet, of a possible signal indicating a habitable zone planet. And Guillaume and his colleagues went ahead to ask for a lot of observing time at ESO La Silla with the HARP spectrograph. That's still the best radio velocity spectrograph on the planet. And he asked to have one observation of Proxima Centauri every night possible. So when there's clear weather, out of the first 60 nights in 2016, and that's what happened. And we got a large fraction actually of these nights observed.
And so we actually just got a question here from a viewer, Sam Rivers on Twitter, who was asking, so as you have been observing this planet or the star system for quite a while, if you see signs of anything like a sign of life, say, is it possible that the star has extinguished already and we are just viewing the tail end of that experience?
No, the star has definitely not extinguished yet. Despite that the light takes over 4 years to reach us, these stars, especially stars like Proxima Centauri, have lifetimes that goes into the billions and tens of billions of years. Much, much, much longer than even our sun. So Proxima is going to be around pretty similar to how it is today, even when our sun has already, evolved into a red giant star and has pulverized the Earth and whatnot.
And so we sort of see that it's probably going to be around there for a while, that we can check on it quite a bit. But in these initial stages, are there anything that stands out to you as being sort of a unique characteristic of this planet that we're starting to look at here?
That's right. So the planet itself, even around a star like Proxima Centauri, is not absolutely unexpected based on the previous results coming from NASA's Kepler mission. So the Kepler planet occurrence rates have already painted a pretty positive picture about how frequent these small planets in the habitable zone of these M dwarfs are. Roughly a quarter of them should have these small planets. The big excitement for us astronomers now is that even the nearest one, Proxima, apparently has one. And that opens up, the door to a fantastic array of possibilities to really detailed characterization of this planet. And many of the questions that I hear nowadays in this past week from everyone about, how does this planet look like? Is it really similar to this artist impression that we see now? Does it have an atmosphere? Does it have a magnetic field? Does it have continents? Does it have oceans? Does it have life, ultimately? Because of its proximity, we might be able to answer these questions in the coming, let's say, decades.
And so what sort of tools do you envision scientists using, or are there plans that you're thinking of in terms of trying to clarify and classify whatever might be involved with this planet, things that you're looking forward to looking into?
Yes. So first of all, we're going to continue observing it with these radial velocity measurements, because I would bet money that there are more planets than just this one in the system. But the signals of these planets are even smaller, so it takes even longer time and more data to pull them out, to significantly detect them. And then, of course, people are currently already looking to see if the planet transits Proxima Centauri. If it transits, the chances are low, just assuming, random orientation of orbital planes. The chance is just 1.5%. So with 98.5% probability, it doesn't transit. But maybe we are lucky again. This would be just absolutely wonderful. If it transits, then we can use in a few years, the JWST to do a detailed characterization to see first whether it has an atmosphere and possibly even search for biosignatures.
And so if it doesn't end up being possible that there's a transit in our future looking and observing this planet, what sort of things can we learn from the radial velocity method? Are there other methods that we can use to glean more information about this system?
Yes, so if it doesn't transit, which is of course more likely, then in the future, what we want is, if we find other planets, they will be further out and possibly easier to directly image. So with the next generation of very large aperture ground-based telescopes that will have a very advanced, high-powered imaging systems, the Giant Magellan Telescope, for instance, where UT Austin is involved, or the Europeans are building the EELT with over 30-meter diameter, this should be then possible, hopefully, that these small planets can be imaged because the star is so close to us. And once you can do that, you can take that light, those photons, and feed them into a spectrograph, and then do very similar things as with a transiting planet. You can, again, look for brightness variations, for extra absorption at certain wavelengths that might indicate, an atmosphere, and even we can possibly model the temperature, density of the atmosphere, and things like this. And in the further future, maybe even again, the ultimate goal is, of course, to search for biosignatures.
And yeah, I think that this is sort of haunting the imaginations of so many people at this point. I know this is way, way speculatory, but if you had to venture a guess, do you think it's more likely that Proxima-b is inhabited by life or not? Would you think one way or the other?
So I think, you have to be careful. Life as we know it here on Earth, we have found in the past few decades, that there is some life on Earth that can live and thrive actually under conditions that are very extreme. And even if the planet is more massive and doesn't even, for instance, have an atmosphere, it's still not clear whether life could not exist in the subsurface, protected, for instance, from all these energetic flares that Proxima typically has. So I would say, I would think that if the process that leads to life, so the first steps are quite common and we don't know that yet, then I think, and once life starts on a planet, then it will stay there, and it will probably, I would say that Proxima-b would be also inhabited at least by microbial life.
That's such an exciting possibility. The hope is out there at the very least. And Michael, thank you so much for joining us here today. It was so great to hear what you had to say about this.
You bet. Thank you.
We're very excited to see where this goes, and I think there's a lot of developments right on the horizon. So coming up, it may be tough for us to survive on this new planet. There's a lot of difficulties, as Michael was mentioning there. But our next guest has another side to this argument. After our short commercial break, we'll be talking to Dr. Lisa Kaltenegger from the Carl Sagan Institute about biofluorescence. But before that, to the thousands of people tuning into the show right now from around the globe, I wanted to take a moment to encourage you to join the expedition to explore the universe with us, which we do every day here at Slooh. Our members aren't passengers, but rather sign on as a working crew to take control of our robotic telescopes in the Canary Islands and Chile to share the most interesting places in space with everyone else in the community. Slooh is social exploration, and together we've already visited over 50,000 different places in the sky and captured nearly 5 million photos. Working as a team makes it easy to learn from each other and share from our diverse perspectives, fueled in equal part by science and imagination, and the human spirit to search and wonder. Who knows, we may be alone in the universe, but you'll never be alone at Slooh. I also wanted to share a little secret with you. A year in the making, there is a new Slooh coming. That's right, smarter and more powerful than ever. We are so excited to show that to you when it's ready. But you are welcome aboard Slooh's expedition into outer space, which is free to try, so do join our adventure into the great unknown. Now, don't go anywhere. We'll be right back after this quick commercial break for more on Proxima-b. Hi there, folks, and welcome back to the show. Our next guest is Dr. Lisa Kaltenegger, director of the Carl Sagan Institute. And so Dr. Kaltenegger recently joined us on the Transit of Mercury broadcast we had earlier this year, where she spoke about her hopes of a future where we've discovered an Earth-like planet capable of supporting life.
And make sure that it's right, then this is going to be hopefully like it's just going to blow everyone's mind in a way, because it's going to change our perception. You can just go out, have a picnic at night or whatever you want to do and say, look over there, there's another Earth, there could be life. You know, that's the time I'm waiting for.
And so there's this excitement, this visceral excitement about the possibilities that this new discovery, many years in the making, may hold for exoplanetary science and our sort of relationship with the universe in general. As we've already learned, this brand new planet is very close to its host star, and so that comes with some difficulties. It's a very active star, and that means there's a chance that solar activity has literally blown away the atmosphere. And add in some UV and X-ray radiation, the possibility of the planet being tidally locked with its host star. This means that one side would be facing the star eternally, and the other would be facing away. That that could cause some difficulties as well. And many are wondering if there's any possibility for life considering all these difficulties that may stand in the way of that. Well, Dr. Kaltenegger is here to tell us all about her thoughts on that subject, including a new hypothesis that could allow for life to survive under these harsh conditions. So, Dr. Kaltenegger, thank you very much for joining us here today.
Thanks for having me, Eric.
Oh, yeah, I'm looking forward to this conversation. And how do you feel about this new discovery? Are you excited? Do you feel like this could be the start of some exciting science?
I have to say the new discovery is really inspiring because just think about it. What more could we have asked for than a planet next door, just around our closest star? And honestly, so Michael gave his take on whether he thinks there's life or not. And that's, of course, one of the big questions that people keep asking. But it's also a really intriguing star, as you pointed out, right? It's not your run-of-the-mill sun-like star. That's kind of boring. Good for us that the sun is boring. We don't have any flares, no violent outbursts. We're good. But it'd be really interesting because you said. So we're looking at Proxima Centauri, and it's a really kind of young star. It's older than the sun, but in its lifetime, it's really early on because the small stars live so long. So from that perspective, it would be a cool place to live because you'd have a long time before you actually run out, basically run out of time because your star is becoming just bigger and bigger. But as you said, there's all these flares. And so there's all this radiation hitting the planet. And so one of the things that we thought about is like, what could you actually do? Or do we know life that could survive it? And Michael was already talking about that we know about extreme forms of life that actually could survive in a place like that with a lot of radiation. But the question always will be is like, could it actually start there? And that's the key point that we don't know. And this is why looking, especially with the 40-meter telescope that we're going to right now building in the Atacama Desert. And, I hope the Slooh network is going to build one too that's that big so it can actually look at Proxima-b itself and catch its light. Then you can have a look at what's in the atmosphere. And as Michael said, maybe if the planet actually transits, so it goes between us and its star. And so basically light of the star gets filtered through the atmosphere of the planet before it gets to us. Then we can also look for signs of biology, like things that you and me breathe in and out. But a question that we had before we even knew that the planet existed, and that was the fun part about it, because we're trying to think out of the box, saying, well, what about if life had to survive around a really active star? And so basically the idea was we looked around in the on the Earth, and we said, the life that we know now, which one could actually do it? Or which one has a mechanism that could do it? And so basically what you see there is that there are some corals here on Earth that if you hit them with a lot of UV light, what they actually do is they start to fluoresce. So they start to actually glow in visible light. And this is a protection mechanism. That protection mechanism basically breaks down the really harmful, violent radiation that the star puts out in the X-ray and UV, and it breaks it down to non-harmful wavelengths, visible light. And for corals, they do that to protect some algae they live in combination with. And so we were just taking this idea and said that, okay, if you had such another world with so much radiation on it, life would probably, if it starts, be very motivated to actually develop something akin to that, to shelter itself. And then this beautiful image started in your mind, and science is really beautiful, I have to tell you. But we basically said, okay, so if you had this huge flare coming from the star and it would hit the planet, then you could actually imagine the whole planet starting to glow. And whether that is true and whether that can happen, I can't tell you. If such biofluorescence life forms would develop on a star like that, on a planet like that, around a violent star like Proxima Centauri, then that should work, or that could work. That's like the thing I'd have to say. But it would be just an amazing thing to witness if we can. Just think about a completely different kind of signature for life that we really didn't think about. And my colleague Jack O'Malley James here at the Carl Sagan Institute at Cornell is the first author in this scientific paper. And we were basically thinking this would be like a science fiction paper. And then, luckily, the discoverers actually offered up Proxima-b. That's exactly such a planet. So one that gets hit with a lot of flares, and it's so close that with the next generation of telescope, the 40-meter extremely large telescope, the European extremely large telescope that we're building in Chile, the 40-meter, we could actually spot such a signal. It would be very feeble, it would be very hard to get, but it would be timed with the explosions of this on the surface of the star. And so it'd be really interesting. And that's what I mean by intriguing, because as you were saying before, a planet next door, incredible and very inspiring, because as a travel destination, it's going to be the closest that we're going to get, even though we need to bring a lot of shielding material for that, because it wouldn't be very healthy for us to land on that planet. But it is a great, great, if you want to test of what life might be capable of. And I think that will be something, if life exists somewhere else in the universe, and I really hope it does. If you ask my opinion, I can't tell you what percentage we have, because we have no idea what it takes for life to start. It could be everywhere, it could be nowhere. But Proxima-b is for sure a great test case that's just very bizarre in a way, a violent star, a planet so close in, getting hit by all this radiation. If we were to find life there, you could basically say it must be everywhere, because it survives this. If it can develop there, it should be able to develop kind of everywhere else too. And that would be fascinating.
It would be, oh, that's just so amazing to hear. I mean, it's stretching the boundaries of our own imagination and what could just be possible around other worlds. And you were mentioning also that since this star has sort of a long lifetime, there's maybe a lot of possibility for things to develop and maybe us to travel there as well. If there was sort of a planet that was filled with these bioluminescent life forms, would we find it, do you think, very difficult for human beings to be near that sort of situation?
I think what we would have to do for humans beings, because we never evolved for high radiation, right? You and me are not doing well with X-rays. You know, you have to do the lead thing when they actually X-ray your bodies to see your bones. And UV, we having the sunscreen, right? You don't want to have it hit you. So we would have to come up with a lot of good shielding, or if there were an ocean, again, we don't know, we would have to dive deep really early on just to escape the radiation, because the ocean can actually shield you. But what is so exciting is that we are on this verge of being able to spot signatures of life in the atmosphere of many, many planets, because the TESS mission is going to launch next year. That's the NASA mission, the next update to Kepler, a small telescope that's going to scan all the night sky and look for transiting planets. So when the star becomes a little tiny bit dimmer, we know that a planet goes between us and the star and dims our view of the hot star just very, very slightly. And so Proxima-b will always be special because it's our closest one, and it's a highly bizarre one. It has violent storms, and I really, really hope that life can survive that and evolve under these conditions, because that would just show you the tenacity of life. And we really hope that there's a huge tenacity of life everywhere, because that just means in the next couple of years, we're in for so many great surprises and treats on all these worlds we're finding out there.
Oh, yes, it would just open the door to some incredible exploration. And so sort of on the subject of seeing these different planets out there, another viewer on Twitter, Tom Courtney, is asking, wondering how this planet was detected if it wasn't through the transiting method, because you were talking a little bit about the transiting method earlier on. So was there a different way that this planet in particular was detected?
The fascinating thing in a way too is that we have not seen the planet. We have not. The discoverers have not laid eyes on that planet. But the way we spotted it is because the star moves, because the planet moves around it and tugs on it while it does that. And it's basically like when you go to a park and you see somebody being, walking a really big dog who wants to go in a direction that the person does not want to go. You don't need to see the dog because you see that the person leans back like crazy not to be dragged in that direction. And so in a way, the planet also tugs on the star, and so the star, metaphorically if you want, actually leans back to counter that pull. And so they are in a rotation, right? So the planet moves around the star, and so if you only see the star, what you see is that the star goes back and forth. It basically makes a rotation, this movement, because it always leans away from the planet. And this is what you can spot in the light of red shifted if it moves away from you, blue shifted if the star moves towards you. And if the star does the red shift, blue shift, red shift, blue shift in its light, the lines in its light, the absorption lines do that. We can see that in the starlight. Then you can say something is tugging on it that goes in a circle around it or in an orbit around it. And that's how we know that Proxima-b is there. And so in a way, it's actually pretty incredible that with the technology that we have, we can spot such a tiny, tiny planet, but also that we really can find planets we cannot even see.
And so there's just a bunch of astronomers that I think were working hard for years to really uncover this signal in the mystery that we see here. And it's amazing to hear about all this stuff. And I was wondering, in terms of what you're looking forward to, it seems like there's a lot of possibilities here right on the horizon. Is there a certain thing that you hope will happen next in terms of how you can look into different things of Proxima-b, or in terms of what you might like to see come announced regarding this exciting new planet?
Oh, absolutely. So what would be amazing, and it's very, very tiny, tiny chance of that, but what would be amazing if it transits? Because if the planet would go by chance, it's always a chance alignment because the planet could be like going like this around the star or like this around the star. But if by chance it actually crosses our line of sight, so it goes between us and its star, then part of the stellar light, as we were saying, gets filtered through the planetary atmosphere, and that would allow us to actually have a look at the atmosphere, at the air at Proxima-b, and figure out if we see signs of life there. And as I said before, we have a new mission that's going to go up in 2017, next year, a tiny one, that's going to find all the planets around the closest stars in both hemispheres. Slooh is very well placed to actually follow up on either of those. But basically, this is what we want to do next. We want to use the James Webb Space Telescope, the one that's the next bigger Hubble. It's basically the largest person you know, 3.5 times as big, well, a bit more than 3 times the largest person you know. Yes, they're a basketball player. So it's 6.5 meters in diameter. And that is the first machine, the first telescope that would be able to collect enough light so that we can tweeze out these tiny, tiny signals that the chemicals leave in an atmosphere of another world. Because light is energy, so when you go out and light hits you, it gets warm. And so if light hit molecules in the atmosphere of a planet, those start to swing or rotate, or some electrons get shot up to another energy level. But basically, when the light then that is filtered through the planetary atmosphere gets to us, the energy that was used to make the molecules swing and rotate and to displace the electrons, that energy is missing. It's basically like a passport stamp that the light has on it. Missing light that tells me exactly what the chemical makeup is of that world. And that's what JWST will, for the first time, be able to do. It's not even far away for small planets. We already do it for big planets. Sorry, for small planets. I'm very excited about the small, rocky, potentially habitable ones.
And so really, fingers crossed that it's a transiting one. That would provide us so much more opportunity, although there is still tons around there. But we're really looking forward to seeing what comes out of all this and wherever you end up having to be in the middle of it. Thank you very much, Dr. Kaltenegger. Thank you so much for joining us here today. We really look forward to seeing what you might do here in the future.
Thanks very much, Eric. And I think somebody should write a couple more science fiction novels because we're getting ahead of this. Nobody has talked about a fluorescence world. Nobody has talked about some other things. Please, the authors out there, come on. We don't want to be in front of science fiction here.
There's new frontiers to explore in these books. Yeah, absolutely. You writers, go out there and do it. But yeah, thank you again. We always love having you here on Slooh. We hope to see you on another show in the future.
Thank you, Eric.
And so, this has been such a fun program. I'm so glad you came along for the ride here on Slooh. We've seen so much about this planet, which has only recently been announced, although certainly years in the making, this discovery. Seeing this place that in a lot of ways shares some exciting similarities to Earth, and also in equal measure exciting differences that can not only inspire our imagination, but can push our scientists to the limit in figuring out what might be going on that planet. And over the next few years, it's going to be, I think, a great trip because we're going to keep learning more and more as people turn their eyes to this system and see exactly what it is that it has to offer. Right there, that small little dot that's circled there in the middle of your screen, that's what we'll be looking at. And boy, I don't know about you, but I'm excited to see what comes out of this. And we even actually have some discussions out there in the scientific world about the possibility of visiting that system, because one of the great things is that it's so close to us. It's so nearby, 4.2 light years away. That may sound like quite a distance, but there are people that are working out there on developing some nanocraft that could potentially be pretty quick on zooming in that direction. These craft that are still in the developmental stages, we're seeing sort of a visualization here, the small little craft that there'll be lasers on Earth that will shoot those craft out into space and toward potentially Proxima Centauri. And these craft would be moving so fast, it'd be about a fifth of the speed of light. So they could potentially reach Proxima Centauri in a couple of decades. So I don't know about you. I think that's postcard distance. I think that's pretty great. So we have so many new things that we can discuss here that in a lot of ways had just been sort of fuzzy conversations. They hadn't been actual physical planets, details that now we can pick into and see some sort of the limits, some of the adventure that our universe has to offer us out there. This is so exciting. But before we go, I wanted to tell you a little bit about the new shows, the next few that are coming up here on Slooh. We have a couple of fun things coming up in the next few weeks. On Thursday, September 1st, we'll actually be taking a look at our star, our sun, and taking in an annular solar eclipse. And it passes over the African continent. So, maybe if you're in Africa or you're flying to Africa soon, you can watch it with your own eyes. But for the rest of us, hey, check it out here on Slooh. We're putting together a string of feed partners to cover as much of the eclipse as possible from one end to the other. So it should be really quite the event. And also on Saturday, September 3rd, we're turning our telescopes over to Neptune for the planet's opposition. And we'll have live views of the furthest planet in our solar system, as long as Planet 9 isn't out there, as it comes into alignment with our sun. And we'll talk about some of the unique characteristics of the planet and why it's one of the few remaining planets we have yet to explore. Should we be sending crafts out there? But who knows? So yes, there's a lot of new frontiers, I think, that have been opened up here in the past few days. And this is really, it's just the start of it. We'd love to hear what you think about this planet, what you think might be happening in the future. Talk to us on Twitter, talk to us on chat. But this is the time, I think, when it's a great opportunity to use our imaginations and see what we think could be out there. It's a great opportunity for us, no matter whether there is life or not. It's expanding our own horizons here as human beings on planet Earth. So thank you so much for tuning in today, and I hope to see you around as new exciting astronomical discoveries pop up, new things happen in the night sky. We'll always be around live showing you the universe right here on Slooh.com.